Just like the previous sample problem, we are asked to use dot structures to determine the formulas of these ionic compounds. Now, you're not going to be told these are ionic compounds on your test. You'll have to get that part on your own. So we have, big clue here, we have metals reacting with non-metals. Why do you keep doing that? Non-metals. Big clue that is going to give you an ionic compound. I'm going to do this one a little bit faster. A. Oh, excuse me. Just had a big kahuna cheesesteak from Jersey Mike's, and oh boy, I'm not making it through this video. Here we go. Potassium. Did we just do this one? No, it's a different problem. All right, potassium, group 1. That tells you it has one valence electron. Actually, let's just skip that part. These all have a 1 positive charge when they lose 1 electron. These all have 2 positive charges when they lose 2 electrons, 3 positive. Right now, these don't form ionic compounds. Going from right to left, halogens, they have 7 valence electrons. All right, so they're going to gain 1 electron. They're all going to form 1 negative, 2 negative, 3 negatives. All right, now let's get back to the problem. Skip those dots for now. Potassium is going to have a 1 positive charge. Iodine is going to have a 1 negative charge, being a halogen. This wasn't necessary, all right? Because you can see it's a 1-to-1 ratio, and you can cross them, and it's going to give you a formula unit of Ki. So let's show that using the dots. Now that we know it's a 1-to-1 ratio, potassium, we've got one of them. It's got 1 valence electron. Iodine has 7 valence electrons, just like the other halogens. Okay, let's draw that transfer of electrons. They both achieve the octet now. It's going to look like this. Potassium gaining a 1 positive charge. Iodine gaining that extra electron. They both have an octet, but we only show the valence action. So there's your answer for part A. All right, part B, aluminum reacts with oxygen. And by the way, I've seen some students in class do the opposite way. Normally we write the metals first, so FYI. Whew. All right, aluminum, oxygen. Aluminum is right here, so that's going to get a... this one, you better use your crisscross method. All right, so that's a 3 positive charge on aluminum. Oxygen, you probably memorized it by now, it's a 2 negative charge. Oxygen right there. Now we can crisscross these numbers, not the charges, the numbers. All right, we've got a formula unit of, we did this in class today. All right, you probably realized that a few minutes ago. All right, so let's draw 2 aluminums, 3 valence electrons each, and we got 3 oxygens, 6 valence electrons each. And let's transfer these electrons from the metal to the non-metal. Okay, you can't get more than that. That's got the octet there, so that's why we need 3 oxygens for every 2 aluminums. There we go. Oxygen can't have more than 8 valence electrons. Some elements can, not the ones in the second period. All right, we got aluminum lost 3 electrons, going to have a 3 positive charge, and oxygen gaining 2 each, so they're all going to gain that 2 negative charge. Let me make these dots a little bit dotty-er. Okay, and we got 3 of these, 2 of these. There's our answer. Oh, let me get that color back. You don't have to use colors on your test, but there we go.